Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1458. Max dot product of two subsequences, right? So this problem is marked hard by LeetCode, right? And this question is asked in Amazon and many other big companies, right? So good problem. So in this problem, you are given two arrays, nums1 and nums2, right? You have to return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length, right? And what is subsequence? A subsequence of an array is a new array which is formed from the original array by deleting some, can be none, of the characters without disturbing the relative positions of the remaining characters. So let's suppose this is array given to you, right? 1 2 3 4 5. So 2 3 5 is a subsequence of this, right? So see 2 3 and let's say I delete this 4 and 5. Okay, so I am getting 2 3 5, right? So 2 3 5 is a subsequence of 1 2 3 4 5, right? Clear? But 1 5 3 is not, because 1 then 5 then 3, but 3 is here now, 3 is before 5, right? So we don't need to change the relative positions, okay, of the remaining characters, right? So we can delete some or can be none of the characters but without disturbing the relative positions of the remaining characters, right? Now let's understand this problem with an example here. So these are the constants. Nums1 dot length and nums2 dot length is from 1 to 500, and nums1 of I, nums2 of I, okay, all these values can be minus 1000 to 1000, right? So can be negative, right? Okay, so here we have to return the maximum dot product, right? So how we need to calculate the dot product? Okay, first thing, so let's say from this nums1 I have to pick one sequence, right? And definitely this sequence should not be empty. So let's say from here I pick 2 comma minus 2, right? I'm not changing the order, right? 2 and then after that I'm writing minus 2. I'm not writing minus 2 and then 2. Okay, same way from here, let's say you pick same length, right? Both should be of same length. So let's say from here I pick 3 and minus 6. Okay, so dot product is nothing but multiplication of these two, 2 into 3, and then plus, then multiplication of these two, minus 2 into minus 6. So you are going to get 6 plus 12, that is nothing but 18, right? Same way from here you can also pick some other sequence. Maybe you pick 2 comma 5, and same way from other side, let's say you pick 3 comma 0, right? Again do this. 2 into 3 is 6, plus 5 into 0 is 0, 6, right? 6 is greater than this 18? No, right? So you can try different combinations, right? So here I'm taking the sequence of length 2, right? Maybe you can try of 3 length, 2 1, let's say minus 2 you pick, and here you pick 3 0 and minus 6. See, 2 into 3 is 6, plus 1 into 0 is 0, plus here 12, right? So again you are getting 18 only. Okay, 18 only. So 18 is the best answer, right? For this problem you will not get any value which will be greater than this 18. Okay, clear? You can try different ways, right? So this is what we need to do, right? So this is nothing but dot product. Clear? Same way in this example number 2, if you take just 3 from here and from here just pick one element, let's say 7, so you are going to get 21, right? Okay, you can try combination of 2, maybe 3 minus 2 pick, right? Here you pick 2 minus 6, let's say 3 into 2 is 6, plus here 12, 18, but 18 is smaller than 21, so 21 is still the best answer, right? So that's why we are returning 21 here. Same way here, example number 3, if you see, uh, if you pick, just take a -1 from here, and here from here you have to take 1. Okay, you can't take empty, right? So one element we need to pick, right, in this sequence, and then if you multiply, you are going to get -1. If you pick both, right, -1 and -1 here, and in this you pick 1 and 1, so -1 into 1 is -1, plus -1 into 1 is -1, so this is nothing but -2. -2 is smaller than this -1, so that is why we're returning -1, right? Max value we need to return, right, the maximum dot product. Okay, so I hope that you guys are clear with the examples, right? Now how we are going to solve this problem, let's see. So this is your nums1, right? Let's take this example, -1 -1. So this is your nums1, and what is your nums2? Your nums2 is this 1 comma 1, right? So you have to find out the subsequence, right? And thing is, one element should be there, right? At least one pair should be there, right? So maybe you start this with this as your I here, and with this as your j, right, starting. So I to end, right, you have to form one sequence, right, starting from I until end, you have to form one sequence, and definitely at least one value should be there, right? Same way from j to end, right, you have to form a sequence, and in this sequence at least one value should be there, right? So this problem is a little bit similar to the LCS, that is nothing but longest common subsequence, right? So this problem is a little bit variation of this longest common sequence. So in longest common subsequence, let's say you have one string like this, A B C D E, and let's say you have one string like this, A C E. Now in this also, right, what you need to do, you have to find the longest common subsequence which is common in both S1 and S2. So same thing, ACE, and here ACE, so of length 3 you have longest common subsequence ACE, right? Okay, so that means you are starting from here until end, and you are starting from here until end, right? You have to find out the longest common subsequence, right? Same way, maybe instead of this, maybe you start from here until end, right? Maybe you start from here until end, or maybe your I is starting from here until end and j is starting from here. So you have to check all the possibilities, right? Okay, so this is nothing but longest common subsequence. So this problem is a little bit variation of it, right? But in this we are just finding out the dot product, and one more thing we need to take care, that at least one value should be there. Clear this part? Okay, right. So now how I'm going to solve this? Okay, so let's do one thing, same example I'm picking. Okay, so here we have -1 and here 1 1. Okay, -1 -1, and here we have 1 comma 1. Okay, now here let's do one thing, let's place your I here, let's place your j here. So now here, what are the different options you have? What are the different options you have? So one option is, we need to pick at least one pair, right? We need to pick at least one. So let's say I pick both I and j, right? So I pick -1, and from this I pick 1, right? Right, I pick this, and after that, let's say I'm going to solve starting from I plus 1 to j plus 1, right? So here this DFS of I, right, it simply means, here if you see DFS of I comma j, it simply means I am finding the sequence, right, and in that sequence one element should be there, but that sequence is starting from I until end and starting from j until end, right? This is the meaning of this. Okay, I to end, j to end, right? I to end, j to end. So here one option is pick one element, right? Minus 1 and 1, let's say you pick, and then you solve the remaining portion. So next time maybe minus 1 minus 1, next time maybe your I is here, and in this side your j is here, let's say. Okay, this is one option, right? Clear? Now see the next option. Next option is you decide, let's not pick anything yet, right? Minus 1 1, let's not pick anything yet. Let's do one thing, let's simply skip I, move to the next position, and let's keep j here only, right? So here I'm doing, I am skipping I, right? Skipping, this is, let's say, first number, this is second number, I'm skipping this one, right? So here what I'm doing, I'm taking both, take both, and then I'm proceeding here, right? Okay, and there is one more option I have, right? Maybe what I decide to skip 2. Skip 2 means this one. So what I do here, I call for dfs, I put it here only, and I ask j, you move forward, okay? You start from the next element. So only these three things I can do, right? I can't skip both. I can't skip both because at least one should be there, right? At least one element, right? So that is why I have only these options to take both. Okay, cool. Or skip any one and move to the next. Okay, from here you may get some result, and from here you may get some result. Okay, so you are solving everything, right? Here both are moving forward, and you are solving. Here only one is moving forward, that is ith one, and here also only one is moving forward, j plus 1, and you already taking one element in consideration. Okay, right? And tell me, I'm having some value here, x, right? Plus, and here I'm getting some value in this, right? So if this value is comes out to be less than 0, right? Then do I need to add this in the overall result? Tell me one thing. No, right? Because overall I'm going to return something from here in the end. I'm going to return something from here in the end. I'm going to return something from here in the end, right? So if you just see this particular tree, subtree, right? So in this side, let's say here I'm getting some x value. In this, if I get some any smaller value, then do I seriously need to pick that particular pair or not? No, I don't need to pick that, right? I can skip, right? So this is just in code, I will just write this thing, that if with the addition of this, if I'm going to get some value less than 0, then don't add it. Okay, if I'm getting some bigger value greater than 0, right, then I'm happy. Okay, I will give the max dot product from this side, right? Okay, let's see like this. Okay, so now here see your I and j both move forwards. Okay, let's see. I'm not going to solve all these. Let's see this part itself. Okay, let's see, I'm solving this part. Okay, now here again you have three options. Okay, right. Now take both. So if you take both, so minus 1 and into 1, and then after that your I is going to move forward, right? dfs I plus 1 and j plus 1. Here same way like above, skip 1. So dfs of I plus 1 and j. Here also dfs of I and here j plus 1. Okay, so now here tell me one thing, in this side, okay, minus 1 minus 1, your I moving outside. Here 1 and 1, your j is moving outside. Here minus 1 minus 1, your I is moving outside, right? And j is still here only, right? In this side your I is okay, I is cool here, but J is angry, right? Because J goes out of bound, right? J is okay, right? Now now here and right, and there is no element, there is no element. So tell me, from this side, for this particular value, what should I return? I should return 0. Tell me, can I return 0 for this part, since it goes out of bound, because there are no elements here, right? So can I return 0? No. Why no? Because 0 is greater than -2, right? 0 is greater than -3, 0 is greater than -1, right? So here in this same example, if you see, our output is -1. So from this side, let's say, from this side, let's say I return 0, okay, and from this side, let's say I return -1 into 1 is -1, okay, and this side, let's say I return 0, -1 plus 0 -1, so 0. So now overall, in the top, you have to return the best answer out of these three, okay, from here, whatever the best result. So you are going to say 0 is the best result, but no, 0 is not the best result here, right? Okay, 0 is not the best answer here. If you use 0, you will give the incorrect answer, right? So what I will do here, answer is not possible, right? If anyone goes outside, so if anyone goes outside, definitely I'm not going to make the pair, right? I to end, I have to select something, J to end, but I is already out, right? So I'm not going to make the pair of this. I can't do the dot product. Instead of 0, what you need to do, return the minus infinity. Okay, same here, return minus infinity from here, and from here, this side, uh, -1 plus, and here this side is minus infinity. But I told you in the top that if this is value is less than 0, right, don't add to this one, right? Don't add to this one, okay? So now here I will not do anything. So from here, -1, minus infinity, minus infinity, what is the best answer? That is nothing but -1. So here I am returning -1 to this part. Now here this -1 is also less than 0. I told you, if this is less than 0, ignore it. And here -1. So from here I am returning -1, right? Same way, you have to solve this part. Again, you have three options. Again, here you have three options like this, right? So in the end, you will see that best is going to be -1. Clear this way, right? Right. So this is nothing but you started from top, right? You started from top, then you solve the smaller parts, right? So this is nothing but your top down approach, right? Top down approach, that is nothing but recursion way, right? Okay, now there may be some cases, right? There may be some cases when you are going to call the same subtree again and again, right? Because this is one bigger tree, right? In this bigger tree, there are some sub problems like this. Then in this, there are some sub problems, okay? There are some sub problems like this, and here also there are some sub problems, but this tree is similar to this tree, right? In both the places, I and j are at same index, right? So if you have already solved this particular tree, you don't need to solve it again, right? Again and again, you can simply return the answer, right? If you have already solved this tree, so whenever you see any other combo where I and j is same in the DFS, and you have already solved this tree here, right? Here you already spent 2 days, let's say, to solve this problem. So again, you don't need to take 2 days, you already know the answer. So I will store the answer, let's say, somewhere, right? So this is nothing but memoization, right? So in this recursion, I will add memoization as well, right? So this is your approach 1 to solve this problem, right? So quickly we'll write the code for approach 1. Then we will move to the approach 2, that is bottom up approach. Bottom up approach, right? So after that we will write. Okay, both the approaches are similar, nothing complex, right? So let's move to the coding part. So here what you need to do, let's pass this nums1 and nums2, right? So here these two things are passed to this method, right? Max dot product. So I will pass this globally in my class, right? So that when I'm going to call the dfs method, I don't need to write these parameters in that method, right? So I will pass them globally in the class. So here I'm just going to write nums1 and nums1, and here I'm just going to write nums2. Clear? And here you have to create one memo array, 2D array, right? Because I and j, both the things are changing, right? And just take one variable negative infinity value that we need to return. Okay, negative infinity is equal to integer dot min underscore value, right? Right. And here I will just initialize. Okay, this dot nums1 is equal to nums1, and this dot nums2 is equal to nums2, right? And here let's say n, right? So let's pass n and m globally as well in the class, int n and m. So n is nothing but, the value of n is nothing but this nums1 dot length, and m is nothing but, let's say, nums2 dot length, right? And your memo is nothing but new int, and here I'm just going to pass n and m. Okay, clear? And here I will simply do one thing, I will just fill all the values in memo as of now, the minimum value. Okay, so int I is equal to 0, I is less than n, I plus plus, and here arrays dot fill memo of I. Okay, ith row. So fill this complete with what? Integer dot min underscore value. Okay, min underscore value, that's it, right? And here simply return dfs and pass 0 comma 0, right? So we are going to start from this, right? And then here I'm expecting this dfs to return me the answer, right? So now I have to just simply write the code for dfs. So here we did nothing actually, just basic steps, right? This we already know why we are doing this, right? In the memo we will fill the values, so we will update the new values in the memo, right? So if in memo at any place if we still find minimum value, that simply means it's not updated, right? That simply means that particular subtree is not solved yet, right? So that's why we use this, right? So you will find one playlist in my YouTube channel, this recursion plus memoization type problems, or in the GitHub 2024 problems you will find one a folder for recursion and memoization. So you will find the same thing everywhere wherever I've implemented memoization. So we used to do the same thing, right? Okay, now let's proceed further. Here private int dfs, and here int I, and here int j. So here base case no elements left, right? No elements left, invalid, right? So this is the case, right? If I is equal to n, I reaches out of bound, or j is equal to m, j reaches out of bound, right? And I'm using or here, or operation, anyone, then just return negative infinity value, the variable that I have created above, right? Negative infinity. Clear? And here, before proceeding, I will just simply check first if memo of I and j value, right? If this is not equal to this value that I filled initially, that simply means I have operated this value somewhere else in some order subtree. So from here, we don't need to proceed further. We will simply return this mem of I comma j, right? Okay. Now here option one, that is nothing but take both. So int take is equal to nums1 of I into nums2 of j, right? And next is equal to dfs of I plus 1 and here j plus 1, right? And I told you that I'm only going to take this next if it is greater than 0, otherwise I will skip it. So take is equal to take plus next. Clear this part, right? So this is done. Okay. Now option 2, that is nothing but skip uh nums 1 of I, right? So here you say int skip 1 and here you have to write dfs of I plus 1 comma j, right? And option 3 is nothing but skip nums 2 of j, right? So here int skip 2 is going to be dfs of I and here j plus 1, right? And you have to return what? You have to return the best answer, math.max of the take, okay, whatever the take value, that is from option 1, okay, take value, or math.max between skip 1 and skip 2, from all these three, whatever the best answer, right? That's what you need to return. Okay, so take, so from here you will get some max, right? And then you are going to compare that with the take, and whatever the max you have to return, right? And I, as I'm saying, right, we have to store this in the memo of I comma j, right? So all these subtrees values I'm storing here. That's it. That's it. Now let's run the code. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And what is the time complexity? Time complexity is nothing but m into n, right? Because we are using memoization, right? We are we are checking all these states only once, right? M into n states, that's it. So m into n is the time complexity. So this is nothing but your top down approach. Okay. Now after this we move to the bottom up, right? That is also going to be very easy, nothing complex for you guys now. Okay, so I will just change this same code. Okay, very easy, right? So in this, what you need to do here, uh, we don't need to use this. Okay, just see it what I'm doing here. We don't need to use this here. Okay, and here you have to just create one variable int n this and int m is equal to this, right? And here I'm removing it. Memoization I don't need, right? This is just for recursion purpose, right? Memoization part I removed here. So this thing is done, right? Int and m, and here this you can take it globally, right? Or if you want, you can take it here in the method itself here, okay, like this, right? And then you have to create one dp, right? So just like a memo, right? So here I will create the dp, and in this dp I will pass how many different states. That is going to be n plus 1 and m plus 1, right? So I am adding one more state, right? That is for my very base case, right? Because no elements left, then that is simply means invalid. So in that case, okay, must pick at least one pair, right? So what I'm going to do here, instead of this, right, I'm going to run this loop until here, right? And there is one more loop that I'm going to run inside this. Okay, inside this I'm going to run one more loop, and let's say like this. And here int j is equal to 0, j is less than m this time, right? And here j plus 1, same thing, same like thing, but I'm just making I and j, right? So here what you need to do, just like memo, right? So in memo I was using single loop, so you can use a single also, right? Or if you want like this, write like this, you can write it like this as well, no issue, same thing we are doing. Okay, so negative underscore infinity, right? And that's it. Okay, this is what you need to do here. So same basic setup we did here, right? I don't need to return anything here as of now. Okay, and here I'm not calling this, right? So now this is a bottom up approach, right? Bottom up approach. So definitely what I need to do here, I have to start iterating from the bottom, right? So here I n minus 1. Okay, I is equal to n minus 1, and here I should be greater than equal to 0, and here I minus minus. Okay, this. And same way for j also, you have to start from the bottom. J is equal to m minus 1, and j is greater than equal to 0, and here j minus minus. Okay, and inside this we will fill the values. Okay, so when you are going to take, so how you are going to do that, it like this, right? So int take is like this, clear this part? Okay, and after that, for the next iteration, right, next iteration, so here what I'm doing, I'm moving I plus 1 j plus 1. So here what I will do, here I will simply write if dp of I plus 1, right, this value, and here j plus 1 value, right? So this is bottom up approach, right? So I am already expecting that in the bottom I have already solved this part, right? So if this is already greater than 0, then only I'm going to take it, right? So in that case, take is going to be take plus this dp of I plus 1 j plus 1, right? This is bottom up filling, right? So this is nothing but fill dp bottom up, right? Okay, and this is nothing but here base case, right? No elements left, right? So this is nothing but invalid, right? So because we have to must pick at least one pair, right? So if the values is negative infinity, that simply means we didn't pick any pair as of now in the bottom. So that's why here negative infinity, this is invalid case, right? So this is what we feel. So if we take this, we have to do this, and in the next part dpi plus 1 j plus 1, if this value is greater than 0, only then add it, otherwise no, right? Okay, now what is the scenario for this skip and take? So here int skip and int skip 2, right, these two things. So I will do one thing here, right? This if part I'm going to paste it here. Okay, skip a 1, and here instead of this dfs I will just simply write here na dp of I plus 1, right? And here I will just write j, right? And here in skip 2 I will remain, let's say, here itself, and move j, right? J plus 1, right? See how I'm converting my same code, right, to this dp, right? And once I do all this, then this is what I'm doing here, right? we have to pick the max of all, right? So here I'm going, and here I will paste it, and I will store this value in the DP of IJ, right? Whatever the value. So, right, so bottom up approach, right? So I am expecting I and j to store the best answer. So math.max of take and skip 1 and skip 2, whatever the best answer here, right? This is what I'm expecting here. And in the end, right, so we are starting from end and here from end. So when my I is 0 and j is 0, that simply means for I also 0 to end and j is also 0 to end. So I will store the best result from 0, right? From bottom I'm starting, and when I'm going to reach the start of both for nums1 and nums2, that simply means until then I will have the best answer with me, right? So here I'm just going to return what, dp of 0 and here 0. This is what I will return. Okay, and this part you can now safely remove, right? This part, that's it. Okay, so let me just format the code and we will fix if there are any issues, right? So this is your overall code, right? Now let's run it. So see, all the test cases have been accepted, right? Good, nice, right? So now you can submit it. This is your DP solution. That is nothing bottom up, right? So I hope that you guys are clear with both the approaches. In this case also time complexity is same, m into n, right? So I hope that you guys are clear with both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.